Okay, this is Unit 9, Objective 6, Extra Practice. This video is designed to be used after you've already watched the notes video for this objective. It's not providing instruction necessarily, although I will be obviously walking through each of the problems. But it's designed so that you've already seen the steps, you've already walked through some of the problems, and you're now looking to kind of solidify that knowledge. This would essentially be kind of like what we would do with whiteboards in class. And so therefore it's important that if you haven't watched the notes video, so go ahead and stop this video, go watch the notes video, come back to this video after that fact. For those who have already watched the notes video and are doing this, like I said, to kind of solidify what they've learned, as I put up each problem, you're going to want to pause the video, try the problem on your own, and then restart the video either when you have an answer that you're ready to check or you are stuck and need kind of a hint or some sort of instruction to get past that stuck point. Okay, there are going to be 7 problems in this particular video, so plenty of practice. You can do as much or as little of it as you'd like. You can even fast forward and find potentially the problems that would most meet your need at this point in time. Okay, so up first we're finding theta. For all these problems, we're finding theta such that theta is between 0 and 2 pi, including 0, not including 2 pi. And the first problem we have is 3 cosine squared 3 theta minus 1 equals 1/2. Okay, so go ahead and pause the video, restart it when you're ready. Okay, so first up we need to isolate our trig function, and so in this particular case that would mean adding this 1 over to the other side. So we have 3 cosine squared 3 theta equals 1 plus 1/2 is 3/2. Then we'd be dividing the 3. So cosine squared 3 theta equals 3/2 divided by 3 is 1/2, right? Or for those who struggle to see it as dividing by 3, you could see it as multiplying both sides by 1/3, if you prefer to think of it that way. And then square rooting both sides, we get cosine of 3 theta equals, and then when you square root, a reminder that it is plus and minus. So this one would be plus and minus root 1/2, which is the same thing as plus and minus 1 over root 2. And for some of us, we are comfortable figuring out what angle would give me a cosine of 1 over root 2. But for those who have memorized it or learned another way, you might want to take a moment and rationalize that denominator. So that would mean multiplying top and bottom by root 2. To give you plus and minus, 1 times root 2 is root 2 times root 2 is 2. And so if you've memorized your trigs as root 2 over 2 rather than 1 over root 2, you might want to take that step. Okay, so next up we're figuring out, okay, what's my reference angle in this particular case? And so for this one we are looking for what would give me a cosine of root 2 over 2, and so you're either thinking of your hand trick or you're thinking of your triangles, or you are sketching out your first quadrant really quickly to check this. Regardless of how you do it, you should end up getting the 45-degree angle, or pi over 4. In this case, cosine is going to be positive and negative, so we're going to name that pi over 4 angle in each of our 4 quadrants, right? So first quadrant is, of course, pi over 4. Second quadrant, pi over 4 angle is 3 pi over 4. Third quadrant is 5 pi over 4. And fourth quadrant is 7 pi over 4. Okay, and so that's one rotation. We now need to figure out, okay, how many pairs do we need in this particular case? How many times am I going to be adding 2 pi? Well, this cosine is rotating 3 times as quickly as it normally does because we have 3 theta instead of just cosine of theta. And so each of these angles is going to repeat itself 3 times, right? We're spinning 3 times. And so we're going to be adding 2 pi to each of these 2 additional times. Okay? Well, adding 2 pi in terms of a denominator of 4, right, would mean 8 pi over 4. right? So that's actually what I'm going to be adding here, 8 pi over 4. So adding to pi over 4 would be 9 pi over 4. 3 pi over 4 would be 11 pi over 4. To 5 pi over 4 would be 13 pi over 4. And 15 pi over 4. And so that's one more rotation through our circle. We've got a third rotation to do, so I've got to add another 2 pi to each of these, or another 8 pi over 4 to each of these. So we've got our, here's my first grouping. Let's make sure we don't lose sight of that. First grouping, here's my second grouping here. So we've got one more grouping to do. So we have 17 pi over 4, 19 pi over 4, 21 pi over 4, and one more 23 pi over 4, adding 8 pi over 4 to each of those. So there's my third rotation through my circle. Okay? And then solving for theta, we are dividing 3 to both sides, or multiplying 1/3 to both sides. So multiplying 1/3, we have pi over 12. This would be 3 pi over 12, or reducing pi over 4. 5 pi over 12. 7 pi over 12. 9 pi over 12, or reducing 3 pi over 4. 11 pi over 12. 13 pi over 12. 15 pi over 12, or reducing 5 pi over 4. 17 pi over 12, 3 more, 19 pi over 12, 21 pi over 12, or reducing 7 pi over 4, and 23 pi over 12. For all of our different answers there. Oops, I said over 4. Oops, that reduces to 7 pi over 4. It is still 21 pi over 12. My apologies. Okay, next up, we have 2 minus 1/5 tangent of theta over 2 equals 9/5. Okay, go ahead and pause the video, restart it when you're ready. Okay, isolating our trig in this particular case means first subtracting 2 over to the other side. Okay, subtracting 2 would be the same thing as subtracting 10/5. So this would be negative 1/5. Let me go ahead and show that subtraction over here for those who would like it. So subtracting 2 from that 9/5 would be the same thing as subtracting 10/5, which would give me negative 1/5 there. Let me zoom in on that a little bit. There we go. Okay, so now we've subtracted the 2 over. You can see that subtraction over here, negative 1/5. Dividing the negative 1/5, we get tangent of theta over 2 equals negative 1/5 divided by negative 1/5 is 1. And so now we're looking to identify what is our reference angle in this particular case. And so then you're thinking about, okay, for my tangent, I need my tangent to equal 1. So you're walking through your hand trick, unit circle, triangles, however it is you prefer to do it. You should land on the fact that your reference angle in this case would be pi over 4. And then I want my tangent to be positive. So we're naming the pi over 4 angle in my first and third quadrants here. Okay, well the pi over 4 angle in the first quadrant is pi over 4. Pi over 4 in the third quadrant is called 5 pi over 4. And then in this case, you're always checking to see, do I have any additional rotations? In this particular case, my rotation is occurring half as quickly. And so if you are comfortable making this assessment, you could already cross off the 5 pi over 4. Right, because we've only gone half as quickly, so where this is one full rotation will hit both of these angles, half the rotation will only hit the pi over 4. If you are sitting there at all insecure about that idea of crossing off the 5 pi over 4 already, you can leave it, because after you solve for theta, you will see that the angle resulting from this 5 pi over 4 will lie outside of our domain of 0 to 2 pi. And so you'll identify that as an excluded value at that point. Okay? So either cross it off now, or solving for theta would mean multiplying both sides by 2 in this particular case. So multiplying 2 to the pi over 4 would be 2 pi over 4, or pi over 2. And multiplying 2 to the 5 pi over 4 would be 10 pi over 4, or 5 pi over 2, which is outside of that restricted domain, like I said earlier. And so it would give us one answer of pi over 2. Okay? Okay, next up we have 14. Wait 1 second, let me get this on the screen here. There you go. 14 sine of 4 theta plus 7 root 3 equals 0. Okay, go ahead and pause the video. Restart it when you're ready. Okay, isolating our trig in this case means subtracting that 7 root 3 over to the other side. So 14 sine of 4 thirds equals negative 7 root 3. Dividing the 14, we have sine of 4 theta equals negative root 3 over 2. And so identifying your reference angle in this particular case, we have our root 3 over 2, so go ahead and take a moment. Sine root 3 over 2, what angle would that be? That would be your pi over 3 angle. And then we want sine to be negative, so we're naming the pi over 3 angle in the third and fourth quadrant, because that's where sine would be negative. And so in this case, my third quadrant pi over 3 angle would be called 4 pi over 3. And my fourth quadrant pi over 3 angle would be 5 pi over 3. And then we're in for a little bit of a process here, because while that is one rotation through my unit circle, take a look at what's inside our sign for this problem. Not theta, but 4 theta, meaning this is being rotated 4 times as quickly. I need to repeat this pairing here 4 times. And so I'm going to be adding 2 pi to each of those. 2 pi with a denominator of 6 would be, with a denominator of 3 would be 6 pi over 3, right? So I'm adding 6 pi to each of these. So this is, adding 6 pi here, 10 pi over 3, and 11 pi over 3. So there's a second rotation. Adding another 6 pi here, we have 16 pi over 3, and 17 pi over 3. So there's a third rotation. And fourth rotation, we have, adding another 6, 22 pi over 3, and 23 pi over 3. Okay, and so here are your 4 rotations. Second rotation, third rotation, fourth rotation. Okay, and then solving for theta, dividing 4 through, or multiplying 1/4 all the way through, we have 4 pi over 12. Multiplying 1/4 here, which reduces to pi over 3. 5 pi over 12. 10 pi over 12, or 5 pi over 6, if reduced. 11 pi over 12. 16 pi over 12, or 4 pi over 3. 17 pi over 12. 22 pi over 12, or 11 pi over 6. Yes, 11 pi over 6. And 23 pi over 12 for my last but not least. Doesn't put me up and over 2 pi, so we're good to go. We've got our answers. Okay, next up we have cotangent squared of 2 theta over 3. I'm sorry. Oops, I'm at the wrong problem. Similar problem. We have 1/3 cotangent squared of 2 theta over 3 plus 2 equals 3. Okay, go ahead and pause the video. Restart it when you're ready. Okay, isolating our trig, subtracting the 2 over, we get 1/3 cotangent squared of 2 theta over 3 equals 3 minus 2 is 1. Dividing the 1/3 or multiplying 3 over, we get cotangent squared of 2 theta over 3 equals 1 times 3 is 3. And then square rooting both sides, we get cotangent of 2 theta over 3 equals plus and minus root 3. Okay, so identifying our reference angle in this particular case. Go ahead and take a moment, think about your hand trick, your unit circle, your triangles, however it is you prefer to think of it. What angle gives me a cotangent of root 3? And you should land on your pi over 6 angle. In this case, we want our cotangent to be positive or negative. Either one works. And so we are going to be naming our pi over 6 angle in each quadrant. 2 theta over 3 equals the pi over 6 angle in the first quadrant is pi over 6. Second quadrant is 5 pi over 6. Third quadrant is 7 pi over 6. And fourth quadrant is 11 pi over 6. Okay, this particular one rotates 2/3 as quickly, and so if you're comfortable again making the assessment about which of these angles would be crossed off, you're more than welcome to do so. I will say this is one that usually people do struggle a little bit more with, because if we only had 3 answers over here, 2/3 of a rotation would be a pretty quick assessment. With 4 answers, you might be sitting there going, I don't know, I'm pretty sure the 11 pi over 6 gets crossed off, but does the 7 pi over 6 as well? I don't think so. But again, if you're at all unsure, take a moment, solve for theta, and then look at your answers and evaluate which one of these then fall outside of that restricted domain. Okay, okay, so operating under that assumption that potentially speaking this is one that's going to be a little bit harder for people to assess, let's go ahead and solve for theta now. So it'd be multiplying the 3 through and dividing the 2, or for those who prefer to think of it, multiplying by 3/2 all the way through, right? And so in this particular case, multiplying 3/2, you'd have 3 pi over 12, which reduces to pi over 4. 15 pi over 12, which reduces to 5 pi over 4. 21 pi over 12, which reduces to 7 pi over 4. So we're still sitting below our 2 pi range. But right here, where we do our 11 pi over 6 times 3/2, we get 33 pi over 12, which reduces to, if I divided a 3 out of top and bottom, 11 pi over 4, which is definitely outside of my my domain in this particular case of 0 to 2 pi. 2 pi would be 8 pi over 4. This is definitely larger than that, so that is not one of my answers, confirming what we were talking about earlier with the 2/3 rotation. And so we've got these as our final answers here, all of which are under 2 pi. Okay. Okay. Next up, we're going to move into some ones that involve factoring. So we've got 3 that lie in that zone for those who are looking specifically to practice their factoring skills here. So first up, we have our 2 sine squared of theta over 2 minus root 3 times sine of theta over 2 equals 0. Okay, go ahead and pause the video. Restart it when you're ready. Okay, so factoring, as I look at these 2 terms here, I notice they have a sine theta over 2 in common, so this is a GCF factor. Go ahead and pull out our sine theta over 2. And so what would I be left inside? Well, when I pull a sine theta over 2 out of this first term, I'm left with 2 and the second sine theta over 2. And in this second term, when I pull out the sine theta over 2, I'm left with root 3. Okay, so we're going to go ahead and now set each of these equal to 0. So my sine theta over 2 equal to 0, and my 2 sine theta over 2 minus root 3 equals 0. Okay. And then solving this, the left side, we have what gives me a sine of 0. And so then you'd be thinking through your unit circle or however it is you prefer to think of it. For sine equaling 0, we know that this is one of our quadrantals here, and so maybe you take a moment and really quickly write out each of your quadrantal coordinate points to help you with your assessment. In this case, sine would equal 0 at 0 and pi. And then technically 2 pi as well, but remember our restricted domain. We're only going from 0 to 2 pi, including 0, not including 2 pi. So our 0 and pi here. And then making that assessment if you're comfortable with it. This is moving half as quickly, so you could already cross off the pi if you wanted to. Or again, if you're not comfortable with that, multiply the 2 through to solve for theta. 0 times 2 is still 0, but pi times 2 is 2 pi, which lies outside of my domain, and so I'd cross off that angle. Okay. Over here we have 2 sine theta over 2, adding the root 3 over, we get equals root 3. Dividing our 2, we get sine of theta over 2 equals root 3 over 2. Okay, and so then identifying your reference angle and all of that for this particular one. Go ahead and take a moment. What angle gives me a sine of root 3 over 2? You should get pi over 3. Okay, what quadrant would sine be positive in? Take a moment. You should get first and second quadrant. So we're wanting to name the pi over 3 angle in both of those quadrants. And so in this case, this would be our pi over 3 for the first quadrant, and 2 pi over 3 for your second quadrant. Okay? Now, this is again where the thinking of it in terms of a half rotation gets a little bit tricky, because it's tempting in this case to want to cross off that 2 pi over 3 because you're thinking like, oh, it would be half as much. But picture for a second the quadrants you have now fallen in, right? Our quadrants in this particular case are the first and second quadrant. If I only did half of a rotation, it wouldn't actually take me all the way through the second quadrant. It would take me up to the second quadrant and then stop, right? And so technically speaking, both of these are still going to fall inside of my domain. I'm not actually going to be crossing off that 2 pi over 3, okay? And I can show that by the multiplying the 2 through in this particular case. So we have our theta equals, if I multiply the 2 to each of these, 2 times pi over 3 is 2 pi over 3. Multiplying the 2 to the 2 pi over 3 over here, we get 4 pi over 3, which still sits inside of my domain of 0 to 2 pi. And so then the question might be, well, what about that half rotation idea? What happened to the ones we were supposed to cross off? Well, theoretically speaking, they were the negatives that would have resulted if this had been a squared that we would have had to have square rooted, getting plus and minus. The third and fourth quadrant pi over 3's, which would have been then tacked on the back here if we had had plus and minus root 3 over 2. They're the two that are getting removed when we are considering a half rotation. So it's the bottom half of our unit circle. Okay? Oh, and I forgot the 0 over here. Okay, 2 more here. We have up first, let's do 8 cosine squared of 2 theta minus 10 cosine of 2 theta. And then we are doing minus 7 equals 0. Okay, go ahead and pause the video and restart it when you're ready. Okay, so then taking a look at this one, factoring. For some people, they're very comfortable looking at this one and knowing exactly how it factors. For those who would like to think of it in a slightly different form, you could change these cosine 2 thetas into x's and potentially make it one that's a little bit easier for you to factor. So maybe instead of cosine squared, we have just x squared, and then instead of the cosine, we have just x, and then you factor that. And so we're looking for two things that multiply to negative 56 and add to negative 10. Okay, the two things that multiply to negative 56 and add to negative 10 are negative 14 and 4. Okay, and so if we broke this up as our negative 14 and 4, we would have our 2x plus 1 and 4x minus 7, and then it's good to always just double check. 2x times 4x is 8x squared. 2x times negative 7 is negative 14x. 1 times 4x is 4x, making negative 10x. And 1 times negative 7 is negative 7. And then we can copy this factor over here, plugging cosine 2 theta back in for x. So 2 cosine 2 theta plus 1. 4 cosine 2 theta minus 7. Okay, and so setting these individually equal to 0, 2 cosine 2 theta plus 1 equals 0, 4 cosine 2 theta minus 7 equals 0. Okay, on the left here, subtracting 1 over, we get 2 cosine 2 theta equals negative 1. Dividing the 2, cosine 2 theta equals negative 1/2. And so then reference angle, our reference angle in this particular case, what gives me a cosine of negative 1/2? Okay, and you should have gotten pi over 3. And in this case, we want the pi over 3 cosines negative, the pi over 3 angle in the second and third quadrants. Okay. And so in the second quadrant, the pi over 3 angle is 2 pi over 3. And in the third quadrant, it's 4 pi over 3. And then we need to repeat that process because this one is rotating twice as quickly, so we're adding 2 pi to each of these. With a denominator of 3, that means we're adding 6 pi over 3. 2 pi would be 6 pi over 3. And so this would become adding 6 pi over 3, 8 pi over 3, and 10 pi over 3. Okay, so there's my 2 rotations. Dividing 2 through then, we get pi over 3, dividing 2 here, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, on the right side of the equation, isolating our cosine, we get, separate this here, 4 cosine of 2 theta equals 7. Dividing the 4, we get cosine of 2 theta equals 7/4. Okay. And then unfortunately, there is no answer for this one. There is no value or no angle value that when we plug it into cosine will give us a cosine of 7/4. Cosine, if you remember back to when we were looking at graphing it last unit, cosine goes back and forth or oscillates back and forth between -1 and 1. And 7/4 is definitely larger than 1, and so there's no way for us to get up to that 7/4. In fact, if you took the time and picked up a calculator, here, let me go ahead and do that, and you plugged, there we go, plugged in the arc cosine or inverse cosine here of 7/4, your calculator will tell you error, saying okay, it's not possible, we can't get to that value. And so there is no solution from this right side of the equation. Okay. Okay, one more here, ladies and gentlemen, and then that'll wrap up our extra practice for this video. We have sine squared of 3 theta minus 3 sine of 3 theta plus 2 equals cosine squared of 3 theta. Okay, go ahead and pause the video. Restart it when you're ready. Okay, so for this one, we are looking at mixed trig again, and so we're going to be using one of our identities to substitute to be able to eventually factor this. Talked about in both the notes video and the homework video some of the ideas about why you would substitute into different places. In this particular case, we're definitely going to want to substitute in for the cosine because we have a singular sine here, not a sine squared. And so if I substitute into sine squared, I won't be able to fully rid my problem of this sine. And so we're going to be using our cosine squared plus sine squared equals 1. Oh, and I guess technically speaking these should be 3 if I want to make it match my problem. And so if I wanted to figure out what would give, or what would be equivalent to cosine squared 3 theta, if I subtract this sine squared 3 theta over to the other side, I get 1 minus sine squared 3 theta. And so that's what's going to be substituted into my cosine here. Okay, now that we've done that substitution, we want to get this equal to 0 so that we can factor. So I'm going to go ahead and add this sine squared 3 theta over. So we have 2 sine squared 3 theta minus sine 3 theta. And then subtracting this 1 over, we have plus 1 equals 0. And so now I can factor. Again, for those who are comfortable factoring in this form, go ahead and do so. For those who would like to switch these into x's momentarily to help them with factoring, you can. This would then be 2x squared minus 3x plus 1. Okay, so we're looking for two things that multiply to 2 and add to negative 3. And so that would end up being negative 2 and negative 1. And so again, double check, 2x times x is 2x squared. 2x times negative 1 is negative 2x. Negative 1 times x is negative 1x for a total of negative 3x's. And negative 1 times negative 1 is positive 1. And so then we can copy that factor over here. Instead of x, we'll use sine 3 theta. And we're good to solve. Okay, setting the two sides equal to 0, we have our 2 sine 3 theta minus 1 equaling 0, and our sine of 3 theta minus 1 equaling 0. Okay, on the left side, adding the 1 over, we get 2 sine of 3 theta equals 1. Dividing 2, we get sine of 3 theta equals 1/2. Okay, so go ahead and think about your reference angle here. Sine of 1/2, what angle would that be? And you should land on pi over 6. And then for this one, we are wanting the pi over 6 angle for sine to be positive, to be in which quadrants? The sine is positive in the first and second quadrant. And so my 3 theta here is going to equal my first quadrant pi over 6 and my second quadrant pi over 6. And then this one is rotating 3 times as quickly, so we need to repeat this pair 3 times. So we're going to add 2 pi. Now 2 pi and pi over 6 is 12 pi over 6. Right? So we're adding 12 pi over 6 to each of these angles. So my second rotation through, adding 12 pi over 6, we have 13 pi over 6 and 17 pi over 6. and then a third rotation through, so adding another 12 pi over 6, we'd have 25 pi over 6 and 29 pi over 6. Okay, and then dividing 3 through or multiplying by 1/3, however it is you prefer to think of it, we have pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 2 more, 25 pi over 18, and last but not least 29 pi over 18, which still doesn't put me up and over the 2 pi. It shouldn't, right? 36 pi over 18 would be 2 pi. Okay, and then on the right side of the equation here, if we add 1 over, we have sine of 3 theta equals 1. So then again, you're thinking about what would 3 theta therefore equal? Okay, well, sine equaling 1 is a quadrantal. So you could jot your quadrants down again. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then you're asking yourself, okay, where in that, or in those series of points is my sine equal to 1? In this case, my sine equals 1 at pi over 2. And again, this is rotating 3 times as quickly, so we need to add 2 pi to this a couple more times. 2 pi with a denominator of 2 is 4 pi over 2. Okay. And so that's what I'm adding to my pi over 2 here. So a second rotation would put me at 5 pi over 2, adding 4 pi over 2. And a third rotation would put me at 9 pi over 2. And so then dividing 3 through, or multiplying by 1/3, however it is you prefer to think of it, we have pi over 6, 5 pi over 6, and 9 pi over 6, or 3 pi over 2, if you reduced it. And there you go.